Good evening, Zed. Hello, Sahel.
Evening.
Sahel, are you there?
Yes, sir. I'm there.
All right. Everything good?
All good, sir. How are you?
I'm also good. So in the last classes, sorry for the background noise. In the last classes we did limits, right? All the formulas, standard formulas, we understood what limit is. So what is limit? To find the neighborhood values. If this is x is equals to a, then what would be the value of this function f of x when we approach the value a? Approach means come from the right side and the left side. When you come from the left side, this is called LHL. When you come from the right side, this is called RHL. Okay, left hand limit and right hand left. So when you are on the right hand side, can I say x would be a plus h, right? A small value increment in a. When you are standing at the left side, x can be a minus h. This thing is clear? Yes or no? Both of you?
Got it, sir.
So this is what limit is. So let's wait 2-3 minutes for other students to join. All right, then we can start the class. Okay, let's solve a question. Check that the limit f of x extending to 1 exists or not. And when does the limit exist? When LHL equals to RHL. All right, left hand limit. And what is left hand limit? Limit extending to a minus f of x. And what is RHL? Limit extending to a plus f of x. All right. So check that limit f of x extending to 1 exists or not. F of x is given as 1 plus x square, and 0 is less than equals to x is less than equals to 1, and 2 minus x when x is more than 1. All right.
Yes.
So how to solve this? Very simple. First we have to find LHL. LHL at x equals to 1. Here the value of a is 1, right? We are checking the limiting value at 1. So checking the value at 1, LHL, we can write limit extending to 1 minus slightly less than 1 and f of x. Thing is clear or not?
Yes.
All right. Now what would be f of x? Who can tell me what would be f of x?
So 1 plus x square.
1 plus x square. Why so? Because when x is less than 1, we have to assume this function. When x is more than 1, we have to assume this function. So here x tending to 1 minus, that means slightly less than 1. So this will be limit x tending to 1 minus 1 plus x square. Now whenever trying to calculate LHL, always put x equals to 1 minus h, that means a minus h, and h tending to 0. So this limit becomes limit h tending to 0, 1 plus 1 minus h whole square. Now you can evaluate the limit by direct substitution. H equals to 0, so 1 square plus 1, this is 2. Who is not clear in this question? Zaid, Sahel, this thing is clear?
Yes, sir.
Now RHL, limit x tending to 1 plus f of x. So limit x tending to 1 plus, what will be f of x? 2 minus x, because x is more than 1. And on the RHL, always put x equals to 1 plus h, h tending to 0. So limit h tending to 0, 2 minus 1 plus h. Put h equals to 0 here. So the answer is 1. So we can say LHL is not equals to RHL. So limit does not exist. This thing is clear?
Yes.
Both of you, Sahel, this is clear?
Yes, sir.
All right, please note it down. Then I'll give you
So
question.
can you scroll up a bit for the question?
All right, tell me when you are done. All right, Sahel done?
Just a second, sir.
All right.
Done, sir.
All right, try to solve the question. F of x equals to 2x plus 3, x is less than equals to 0, 3 into x plus 1, 3 into x plus 1 when x is more than 0. You have to find limit x tend to 0, f of x exists or no. All right. Try to solve this. Hello, Ginza. Everything good?
Yes, sir.
All right, we solved one question. Let me give you a quick review of that. We tried to find limit, right? We uh, studied all about how to find limits. So we are applying that concepts in questions. So when does the limit exist? When LHL equals to RHL. I told you LHL and RHL in the last class also. LHL is when we approach to the limit from the left side. RHL is when we approach to the limit on the right side. So if we are finding the limit at a point A, then RHL will be A plus H, right? Slightly more than A. LHL will be A minus H, slightly less than A. Okay. So if limit exists, then LHL will be equals to RHL. And this is how we write LHL, limit f of x tending to A minus. That means slightly less than A. A plus means slightly more than. Isn't this clear, Kinza?
Yes, sir.
Alright, so we solved one question. Check that the function limit f of x tending to 1 exists or not. Function was given as 1 plus x square when 0 is less than equals to x is less than equals to 1, 2 minus x when x is more than 1. So we try to find LHL. What we write, limit f of x tending to 1 minus, because on LHL always write 1 minus a minus 3 minus, because x is less than 1. So f of x will be this function, because look at the conditions. When x is less than 1, we have to assume this as the function. So if this is the function, we write f of x equals to this. Now when evaluating LHL, we write x is 1 minus h, where h is tending to 0. Why 1 minus h? H is a positive quantity. So if you subtract some positive quantity from 1, this will be slightly less than 1. That is why this is called LHL. Now substitute value. Use direct substitution. LHL is 2. Same as RHL. Limit f of x 1 plus. If x is more than 1, 1 plus means more than 1. So we have to assume this as the function. So 2 minus x. Putting x equals to 1 plus h is tending to 0. Substitute the value. Direct substitution. RHL is 1. So we can see LHL is 2, RHL is 1. So they are not equal. So limit does not exist. Is this thing clear, or was it too fast? Kenza?
Yes, sir.
All right, Zaid. So Kenza, try to solve this one, this question.
Okay, sir.
No worries, Zaid. Please redo this. No issues there. Sahel, Kinza, have you solved this?
Done, sir.
All right. Kinza, what about you?
I have done the LHL, sir.
All right. I'll give you one more minute. Try to solve that. RHL.
Yes.
And Sahel, are you getting the answer? If limit exists or not?
Doesn't exist.
Does not exist. All right. Let's see. First would be finding LHL. This would be limit x tending to 0 minus f of x, and f of x will be 2x plus 3. So putting x equals to 0 minus h, h tending to 0, limit h tending to 0 to 0 minus h plus 3. So limit h tending to 0, directly put h equals to 0, so 0 minus 0, 0 into 2 is, this is 3. LHL we are getting 3. RHL, limit x tending to 0 plus 3 into x plus 1. So limit x tending to 0, or put x equals to 0 plus h, h tending to 0, this is h tending to 0, 3, 0 plus h plus 1. So directly put, this is also 3. Right, Sahel?
Okay, I think I made a mistake. Instead of substituting x, I substituted h. Okay, I got it.
Got it. So LHL equals to RHL, and this is 3. Absolutely correct, Zayed. Kinza, got it? Yes or no? Kinza, I cannot hear you.
No, sir, I didn't get the correct answer.
You did not get the correct answer.
No, sir.
All right. What went wrong? This is clear, right? The solution.
No, yes, sir, this is clear.
All right. Note it down. I'll give you another question. Here f of x is 2 minus x when x is greater than or equal to 0, 2 plus x when x is less than 0. You have to check if limit x tend to 0 f of x exists or not. All right. Hello, Aman.
Hello, sir.
Why are you late today?
Sorry, sir. I was sleeping.
Sleeping. Nice. So you missed a few things. We are checking how to find limits in questions. All right. So you can
Okay, sir.
see this question and learn about this. We find LHL and RHL. LHL is slightly less than 0, and 0 means the value where we are finding the limit, and RHL is more than that value. So 0 minus 0 plus. In this question, we are trying to find the limit at 0. All right.
Okay,
Look
sir.
at this question. See if you can check this, like find this out. Have you guys written down this question? Sahel, Kinza, everyone?
Yes, sir.
No. Emma, just give me 1 minute. Let them write the question. This is the question. All right. Try to solve it. All right, Sahil. I'm getting different answers from both of you. Kinza, have you solved this?
Yes, sir.
What answer are you getting?
I got 2 for both
So limit
LHL and RHL.
both. All right. So let's check. Aman, have you tried solving this?
Yes, sir, I'm still doing it. I was copying the question before that.
All right. You can check this out if you are confused. So first step is we find LHL. Whenever they ask you if limit exists or not, then find LHL. What is LHL? Limit at what point we are finding 0. So limit x tending to 0 minus. In LHL we write a minus. All right. So this is f of x. So limit x tending to 0 minus. What is f of x? X is tending to 0 minus. That means slightly less than 0. So when this is less than 0, this is the function 2 plus x. So limit, we can put x is 0 minus h tending to 0. Limit h tending to 0, 2 plus h, 0 minus h, put h equals to 0. So this is 2. Direct substitution, always apply direct substitution, factorization, rationalization, and so on. All right. Now RHL, limit x tending to 0 plus f of x. Sahel, are you saying something?
I have doubts, sir. Like,
Ask.
how did x equals 0 minus h? It should be 1
sorry?
minus. How is it like x equals 0 minus h?
Let me explain. See, if this is the point where you are finding the limit, all right, x equals to a. What is LHL? Left hand limit. All right, left hand limit means we are approaching to the point A by left side, from left side. All right, you are moving like this. So when you are standing just before A, your value must be slightly less than A. Yes or no, Sahel?
Right, sir. No,
So
what
can I
is
write
0 here? So my doubt is 0 is a, right?
0 is?
A, I mean like a minus
Yes.
h, right?
Yes,
Got
0
it.
is A here. All right, and H is a very small positive quantity always.
Okay. H will become 0 then, right?
Yes, because when
Okay, so
we write A plus H, H must be tending to 0 if this difference is very small, right?
right, sir.
So
Okay,
this is
got it.
all right. Limit x tending to 0 plus 2 minus x. Put x equals to 0 plus h, h tending to 0. Limit h tending to 0. 2 minus 0 plus h, direct substitution, so 2. So LHL equals to RHL equals to 2. Everyone is clear about this? Yes or no? Aman, this is clear?
Yes, sir, it's clear.
All right, note it down, everyone. Done, everyone?
Yes, sir.
All right. So this is all about limits. Now let's come to continuity. Right? This is all class 11 topic that we did. Now we have to do class 12 topic, that is continuity. So what is continuity? Can anyone tell me if this function is continuous or not?
Yes.
Yes, right? Everyone, this is clear. Why so? We can easily see there is no breaking here, no break points, right? This is very smooth and continuous graph. So this is what basically means. If you can draw the graph without lifting your pen, then the graph is continuous. If there are no breaks on the graph, then the graph is continuous. You can write down, if there are no breaks in the graph, then graph is, or function is continuous. And this is very intuitive way to understand, right? This is not mathematical way. So what does mathematics say? Mathematics says if if limit x tending to a, f of x is equals to f of a for all a belongs to domain of f, then f is a continuous function. Write it down. I'll explain what this means. All right, done, everyone? Sahel Kinza Eman, done?
No, sir. Still writing.
All right. Raise your hands when you have done this, like done writing this. Done, Kinza?
What is it belongs to?
This limit f of x tending to a equals to f of a for all a belongs to domain of f.
Okay, sir. Done, sir.
So what this basically means is, if suppose you are wearing a watch, right, and the watch breaks, so what happens? There is no connection between one point to the other point, right? This is what basically continuous is. What this statement says, limit of f of x at a must be equals to f of a. Suppose this is a graph. We are checking the continuity at x equals to a. We are trying to find if at x equals to a this function is continuous or not. So what we want to check? The neighborhood points, right? If this is the watch, here is the break, and the neighborhood points must be broken. So what we are checking, the neighborhood points and the value of the function at x equals to a. If they all tend to or point to one point, then obviously the graph is continuous. If the left neighborhood says this value is 3, right says this value is 4, then obviously this is not continuous. This is clear or not what I'm saying?
Yes, sir.
Yes, sir.
Right? So let's break down this into few parts. Conditions where a function tends to be not continuous. Alright. What is the first condition? Limit extending to a f of x exists and f of a exists, but they are not equal. Graphically, what we have to understand? Suppose this is a function. This point is x equals to a, and this is the point on the graph. What this is saying, if you find the LHL at a, this, then this is the value. If you find RH, then this is the value. So limit exists. LHL equals to RHL. Limit exists. But if you find f of a, then f of a is here, above the graph. So their neighborhood point to the same thing, but the value of the function lies above the graph. So obviously the graph is broken. This is not continuous. This thing is clear what I'm saying? Yes or no?
Yes, sir.
Yes, Sahil. See, LHL equals to RHL, but that is not equals to f of a. Yes. All right. So what we have to do, always find limit, then find f of a. If those are equal, then function is continuous. What is the second case possible? Limit may not exist. The limit itself may not exist. Like what? If this is the graph, this is the point, x equals to a. If you find LHL, then the neighborhood point on the left side says the value is 3. If you find the RHL, the value will say 4. So the neighborhood points disagree on the common point. So we cannot say this graph is continuous. Yes or no? Yes or no, all of you?
Yes, sir.
Right, Zaid, this is clear? Zaid, Sahel, this is clear?
So can I explain again once?
All right. See, suppose this is the graph. All right, this is the function, and I am finding the continuity at x equals to a. This is x equals to a. So if you just move slightly left, then the value is this 3, right? Sahel, yes or no?
Still not getting it, sir. Like,
Let me explain by some other method. Suppose the stairwell of your house. All right, stairs. All right, you are standing here
Right.
and walking. All right. At this point, if 1 foot you move to your front, that means on the right, then the floor is on the same level. If you move one on the left, then the floor is on the same level. So this is the flat surface. Can I say yes or no?
Right, sir.
But suppose you are standing at this corner point. If you move your foot slightly forward on the right, then the right hand side floor is this, right?
Right, sir.
This is
97.
RHL.
Right.
But if you move slightly backwards, then this is LHL, this floor. Yes or no?
Yes.
Yes, sir.
So at this point, at this corner point, suppose this is x equals to a, can I say limit does not exist because RHL is showing this, LHL is showing this? Yes or no?
Yes.
Yes, sir.
So if limit is not existent, then can I say this is continuous graph? Yes or no?
No, it's
No?
not continuous.
Obviously. So if limit does not exist, then graph is not continuous. Now you can see if this is the graph, this is the corner point, left hand side says this, right hand side says this, so graph is not continuous. All right,
Got it, sir.
note it down, these 2 points.
Sir, can you scroll up?
Done, everyone?
Done, sir.
All right, there is one more point on which limit, or sorry, continuous function will not be possible, which is If function is not defined, at x equals to a, that is f of a does not exist, right? So here limit exists, right? Limit exists, but the function is not there at x equals to a. So how would you have to draw this graph like this? Because at x equals to a, the graph is not present, the function is not defined, right? This thing is clear? Yes or no, everyone?
So again.
All right. Let me explain by another example. Suppose Kinza, you make a plan to hang out with your friends, all right, to play video games. So you and one of your friends, suppose S comes, you guys play. There is another friend R who only you know, all right. S does not know her. You invite her also to play. You guys play together. Everything is going smooth. This is a continuous function. Suppose you invite both of them and you became invisible. All right, you go to the market. They both do not know each other, right? Even though they love the same video game, but if you are not there, then this will not be very smooth. This conversation will not be very smooth, right? Yes or no?
Yes, sir.
Same thing here. The left hand side says 4, the right hand side says 4. LHL equals to RHL, limit exists, but the function itself is not present at x equals to a. That means f of a is not defined. No matter how much the neighborhood says agree with each other, if the function itself is not present, then how would this be continuous? There is no point here to plot, right? So this will always
Yes,
be vacant, right?
yes, sir.
So this is not continuous. I hope this is clear to everyone.
Yes, sir.
All right, Aman, Sahel, Zaid.
Yes.
Yes, sir. Clear.
All right, note it down. So these are the 3 conditions. Note it down. Very simple, in very simple terms, always find limit f of x tending to a, and this must be equals to f of a. If this condition is satisfied, then the function is continuous. If this is not satisfied, the function is not continuous. All right, this is clear. Note it down. All right, Zaid. Done, everyone?
Yes, sir.
All right, so let's take a this is all for today's class. Now there is a test, all right, of the previous topics we did. All right, everyone okay? Sahel, Kinza, Iman, Zaid.
Like a surprise test.
Not surprise, like 3-4 questions are there, half an hour test.
Okay.
All right,
Got it. Sir.
got it. But the
Okay.
results will be there, yeah, in the report card. So you can see this is a surprise test. But I'll be taking a test every week or every other week. All right. So be revised accordingly. All right.
Yes, sir.
So let's give me 2 minutes. I'll share the question paper. No, sir. This is a question of differentiation. All right. Continuity and differentiability chapter. All right. You guys can see the question paper.
Yes, sir.
Yes, sir.
All right. So this is solve any 4. You guys can solve 4 questions in half an hour, right?
Yes.
All right. So you can solve any 4. There are 6 questions. Sahel, please try to rejoin because everyone can see the paper. All right. Well, let's make this any 3. All right, let's make it more easier because this is a surprise test. You guys might be a lot surprised. You can solve any 3 questions and that would be enough. All right.
Yes.
You guys have 30 minutes. And how to send the question like answer sheet? Make a PDF, write your name, then send me on the group. All right.
Sir, I'm not in the group.
Not in the group. I don't think there is a group for you guys, right?
No, sir.
Already you can send me on WhatsApp if you have. Just give me 2 minutes. I'll let them know to create a group. All right.
Okay, sir.
Then make a PDF, write your name, and send that on the group. Sahel, now you can see the question paper.
Yeah, sir.
And you have to solve any 3 questions. All right, not 4. You guys can send the answer sheet on the group or the WhatsApp number that you get links from, right? The Zoom link or any conversation
Yes,
you.
sir. Okay.
Our team member Sana is there, I guess. You guys know her. But please make a PDF and write your name on that.
Sir, in the second question, I have a doubt.
What is the doubt?
Sir, it says if x to the power m and y also to the power m, it should be y to the power n, right?
Yes, you can solve using both. Both are solvable. Whatever you find right, right? No
Okay.
issues. All right, Zaid, you can send the answer sheet, make a PDF, write your name. Last 5 minutes, guys.